Okay, guys, now we're going to talk about reflections. Reflections are a little tougher to explain algebraically. I'm going to do that briefly, but are very simple to visualize. And the key thing you need to understand about reflections is that each point, I'm actually going to write this here, each point be an equal distance from the line of reflection as the pre-image. That's kind of a fancy way of saying every point on your image, the translated image, the reflected image, not translated, I apologize, the transformed image should be equidistant or the same distance from your line of reflection as the original point, just on the other side. The easiest way to explain it is this. If you walk into your bathroom and you look in the mirror and your reflection is a different distance from the mirror than you are, well, some bad stuff is happening, and we need to burn that house down and just start over. Same thing with these reflections. We do not want to find ourselves in a situation where our reflection is a different distance from the line of reflection than the original image. So to start off, we are going to look at a couple images that I'm going to pull up really quickly, and then we're going to jump into these two, which are a little tougher just because of where the line of reflection is. So what we're going to be looking at is our kite here. We're going to call it kite QRST. So kite QRST. And I'm going to show you a couple different reflections so you can get an idea of what I mean by this. We're going to start by, in red, we're going to reflect across the x-axis. So my biggest piece of advice to you here is always, always, always clearly identify your axis or your line of reflection rather. It just makes life easier in the long run. So here we go. I'm going to, in red, draw a line of reflection, which is right there, the x-axis. Now what I have to do is this. I have to determine the distance of each point from the line of reflection. So I'm going to start off just visually showing you this by saying, okay, S is 1 away from the line of reflection. So I've determined the distance to the line of reflection. S is 1 away. So now I need to put S 1 away on the other side. That's going to become S prime. And you'll notice it hasn't shifted or changed at all. It hasn't gone left or right. It is moving directly toward the line of reflection. It creates a perpendicular angle or a right angle. So we're going to do the same thing now with R. We lightly sketch this line. We see that it's 3 away. So its reflection should also be 3 away. And that creates R prime. We connect those lines. T, 3 away, 3 away. This is going to become T prime. And again, I'm verifying that all of these are creating right angles. So I know that I am moving the correct direction. And then finally, Q. Well, Q is kind of weird because I have to go through S, but that's okay. We're going to go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This creates Q prime. Now, when I do this, I have now successfully reflected this kite over my line of reflection, which was the x-axis. Now, when I look at this, the key things I do to check myself, because when I look at it, and I'm sure some of you are looking at it and saying, well, that looks pretty much identical to the original image. So did we just translate it? The easiest way to see that is to look at our labels. Our labels here tell us that Q was the furthest from the line of reflection. It was on the bottom I'll show you this in just a second once I clean up these lines a little. Q was the furthest from the line of reflection. It was on the bottom, and now Q prime is on the top. It is still the furthest from the line of reflection. So that's our easiest way of knowing that we did not translate this. We did reflect it. Now, in blue, I'm going to show you what this would look like across a different line. And in this case, we're going to do blue across a kind of confusing one. We're going to do it across x equals 1. Now, over the course of the year, we've been kind of practicing some of these, and I hope you recognize this. The x-axis is going to be a left-right line, like we just did. X equals 1 is not. X equals 1 is right here, because that is where x is equal to the value of 1. So please don't get confused when it asks you the difference between like the x-axis and x equals 1. Same thing would be true for the y-axis if we were to do it across the y-axis here in green. I know it's kind of counterintuitive, but please just make sure that you are carefully labeling your line and you know what you're talking about. Now let me get rid of that line so I don't end up confusing myself. Great. So in blue here, we're going to do the same thing. We have to say, all right, how far is R? Well, R is 1, 2, 3 away, creates a right angle. 1, 2, 3 away. Here is R prime. S is 5 away. So S must be 5 away. Nope. That's prime. Q is 5 away. The Q prime must also be 5 away. And then T is 8 away. So it must also be 8 away. There we go. And we have now successfully reflected the image across the line of reflection. I'm going to show you an algebraic way to do this. By the time you watch this video, you will have already seen this in class. But the easiest way to do this, if you aren't given a graph or an image, if you're given an image, please just draw it as we just did. But if you were not, we have to do this. You're going to say S. Well, where was S originally? Well, it's at -4, -1. -4, -1. And we need to reflect it across x equals 1. And it's going to give us a resultant image called S prime. Well, we've already drawn where it is, but I want to show you how we do this. I'm going to say to myself, okay, which value are we concerned with? Well, we're concerned with x. So my y value is going to stay exactly the same, -1. So now what I have to ask myself is, what is the difference between 1 and -4? Well, the difference between 1 and -4, hopefully you see, is 5. Okay, so we know the difference is 5 from the point and the line of reflection. Now the last thing I have to ask myself is, okay, if I go 5 to the other side of 1, what would I get? Well, -4 is to the left of 1 on a number line, so 5 to the right of 1 on a number line is 6. And we see we got a 6 and -1. Now, we're going to try this with R. R was originally at -2, -3. I'm translating across x equals 1 to create R prime. Well, same thing. All I care about here is my x value. So my y value is going to remain -3. And then I say, what's the difference between -2 and 1? hopefully you see that as 3. So then I say, okay, what is 3 to the other side, otherwise known as to the right of 1, our line of reflection of 1? Well, it's 4. We come over here and we see, in fact, that is at 4, -3. Same thing we can do over here. Do it one more for you. We'll do Q. Q was actually, let's do one that doesn't have any of the same values. Let's do T. So T was at -7, -3. -7, -3. Translating across, or what am I talking about? Reflecting across. X equals 1, which means I do not care about my Y value, which is going to remain -3. -7 is 8 away from 1. Hopefully you're able to do that in your head. 1 minus -7 is 8. So then I say, all right, well, what is 8 to the other side of 1? Well, it is in fact 9, which is where this ended up. Now, the last part is sometimes, we're going to come back up here, sometimes the line of reflection is going to go directly through your image. And I'm just going to show you what that looks like really quickly. We'll do this in red just because it's a little easier to see. My line of reflection is X equals -1. So what's going to happen here is actually a little strange. Each of these images, or each of these points, is just going to reverse itself. So all this did was spun the shape straight down the middle. So that is my reflection. Same thing here, Y is -2. I say this is 1, 2 away, so 1, 2 away. This is 1, 2 away, 1, 2 away. And then this point is directly on the line of reflection, so it's not actually going to change at all. And that's how we reflect an image when the line of reflection goes directly through it. Hopefully that was helpful. Please reach out with any questions, and have a good night.